Okay, I'm going to make some extraordinary claims here. I've been studying rocks for many years, and these are in front of you are what is, you look at them as rocks, but they're mud fossils. And what I mean by that is they're creatures that were compacted in water and mud, and I believe it was from floods, and they're compacted in these wet conditions, and fascia in the skin and in the body keeps you separated from things by fascia, and your organs are separated. That's why you end up with lungs and hearts and kidneys and all kinds of different things. And they're all apart here, and I'm going to explain all of these things. And the mud fossils, and they turn into regular meat, and sometimes the lungs get bleached out, the blood gets bleached out and leaves all the porosity, but you can still see some ferrous materials that are in them, and some of them actually bleed, and that literally bled. This is an apical tuft from a finger, and any anatomist will know that. It's the tip of the finger, and that is a carbon, they call it a carbon silhouette. It's really, I think, from ferrous oxides, the O2 type oxide of ferrous turns black, and it's the same, it stains just like that stains. This is the iron that's in these bristles, and it stains. And some of them have the veins right in them, which is this one does. You see that? That still has the veins in the arteries. And they blow out the artery side, but not the vein side. And that is where tendons latch on and holds fingers so that they can articulate like this and do all kinds of things. And that's from a giant phalanges. And that's been DNA tested, and that is human. It's gigantic, so that's what we got. And there's another one there, and this one's been DNA tested. That's human. That's the size of a normal human lung. And there's other stuff. Skin has been DNA tested. That's another giant. And it's human too. So I'm going to show all this and prove all this. So don't tell me about the names of Forsterite and tectonic this and all of this stuff. Forget all that, because it doesn't pertain. These are all were creatures, and they've all not been understood. They've been considered granites and this and that. Well, call them whatever you will. These were creatures, and I'm going to show the creature part of them. Very, very simple, and the chemistry proves it out 100%. And they've been DNA tested. 7 CAT scans, 3 DNA tests. It's not, an anatomist has looked over all these CAT scans and talked about all the different stuff. He goes around the world teaching people how to do autopsies. Very, very, very skilled. There's no question about what I'm showing you, and the chemistry is recreatable. And what happens is skin, which coats all the creatures, literally most of the creatures, is heavily laden with silicon. Silicon gets invaded by the water with the oxygen, and it creates SiO2, which is sand, silicon dioxide, feldspars. There's no question what it is here, so it just needs to be peer reviewed and checked. So I'm going to show you about tendons, which make up most of the world because they just don't disintegrate. They're highly mineralized, and they're what's left over after the volatile organics and compounds of your body vaporize off and give off biogases and sublimate away. And the longer they're in the ground, and the more pressure and the more heat, the more things pass on away from that material and leaves the structural components, which are the minerals and the metals and the calcium and the phosphates and all that business. But now some of that stuff is highly ionic, and it becomes invaded by other metals and minerals that are in the percolates, and they attach to the resident matter, which is encapsulated because the skin literally plates these creatures, because the SiO2 creates literally just like plating a cheap ring, because there are electric currents in the ground. It all relates. It's all done. It's all figured out, and it just needs to be tested. And I'm not just guessing. I do have a background in chemistry, and this is this kind of stuff that I did for many years, and I understand this stuff very, very, very well. And I don't think many people have as deep of an understanding of how molecules and elements bond and work together as I do. So that's just the way life is. And I've been doing this forever. So that's what it is, and now I'm going to show you my evidence. All right, I'm going to go right into this real quick. It relates to kaolin clay. Now, these guys, Geopolymer Institute, they're in France, and they do a fabulous job. And what they did was they try to recreate how the blocks of stone at the pyramids were made. And they took limestone from France, literally, limestone there, which it was made of shells and so forth. It's called marine limestone. And it is calcium CaCO3, which is limestone. Now, there's other forms of limestone that are from creatures. Now, and I'll go into that in a minute. But the two different types are, one of them contains kaolin clay, and the other doesn't. And kaolin clay is literally skin and connective tissue. Now, that is not in the marine fossils. And here's what I'm saying, and they show all about this. You can read this whole thing, but they go through the chemistry, and that's my background, is chemistry of things, how things come together. Now, this is the chemical formula, and these are all the same things that are in the body, the same minerals and metals. All the other things sublimate out, and they vaporize off of bodies when they die, and that's what creates the biogases and so forth that are in the ground, methanes and everything. Now, and that's all fully understood. This is all the chemistry of it, and it's totally understood. And they were correct that you can grind this stuff. Here's a soft limestone. They ground it all up like that. They put in the lime. They did this. They added the cement, and they made limestone concrete. And they made the blocks, and they were fine, and they were perfect. They were exactly what they were hoping to find. Now, here's what they looked like when they were done, and they had seashells in them. That tells me that they were marine limestone, which is CaCO3 with no kaolin clay, because there's no connective tissue. Now, the limes, and they admit it in here. They say somewhere down here, they say that wherever it is, they here it is right here. What they did, we have disintegrated this soft material with water. That's the carbonaceous marine sediments, the CaCO3 limestone with the shells. Then they mix the muddy limestone and its fossil shells with kaolin clay. That's what makes bone china, and that's used to coat your skin. It's literally skin. It's the connective tissue kaolin, which is like keratins and keragens, and it's called kaolin clay. And they made a simple polymetric binder, because that's what it is. It's the binder of skin. It's all chemistry, and all of the other stuff boiled away. So then they took the limestone mud, was packed into a mold, and they re-amalgamated it into limestone. But you see, it has all these shells and things in it, and they had to add the kaolin clay. When it's a tendon, you don't add the kaolin clay, it's part of the tendon. And they come out in literal blocks, just like a square block of stone. And the stones at Baalbek are tendons. And the basalt columns that come out of the ground are tendon fibrils. And those tendon fibrils are coated with fascia. And the reason that all of these things come apart in sections just like they are in the body, and your organs will separate out and they turn into mud fossils, and the fibers in basalt and all that stuff is minerals that are in your body. And once they become mineralized and they take on the other things in the percolates that are in the water that are in the clays and so forth, turn them into mud fossils, they turn into these minerals. And as they do, the fascia that normally separated out every single literally fiber in your body is separated by fascia. That's why you don't all glue together. And it is sort of gluey, but it separates out, and that's why you see lungs and hearts and bursas and all that stuff. They're all separated from everything else. And when it's in a wet environment, it turns into stone, and the fascia continues to do its job because it's meant to separate things. That's what it does in life. So anyway, that's how that works. All right, now this was from a video called Strolling Under the Skin, and it's excellent. And I'm doing this under the Fair Use Act. I'm just commenting. There's no money to be made here. Now, watch what happens. I'm going to play it and just listen to this. Look at this. This is what I want you to see. You see that? Hold on a second. Now, this is a flexible tendon. At this point, it's just been removed from the body, and before they even squeeze it, no blood comes out here. What it's showing you here is that right in this area, there's these tiny little vascularizations. Let's come back here. Now watch when it comes out.
The very foundations of the classical school of thought.
Okay, see it? You see it start to leak out of here? This is all floppy and gooey now. But when they set up in the body, they turn into squares. They turn into solid squares. And that's what you see at Lebanon. And that's what you see at the Baalbek stones. And they have this little bloody vascularization around here. And you can see this. And there's just virtually no question what they are. And around the outside of them will be that vascular stuff that they showed here. All of this, well, you'll see it in a minute here. Let's follow this a little further because it's very, very fascinating.
Relationships between the tendons, the sliding sheaths, and the vessels.
This sheath slides around that, and that's how they can move in the body.
During the revascularization following the release of a garret, we observed that not only the tendons extremities bled with an apparently circular longitudinal and peripheral vascularization.
Now, you see this part in here? That's what turns square. Hold on. You see these stripes coming down here? Whoops, hold on.
The greater the longitude per vessel, whose bump is slowly receding as the
see these stripes?
Maximum.
Those are the boards. They're literally boards, and they turn into squares. I'm telling you, that's just the way it is. And where these meet, the gooey stuff in your body, it's called an abrupt transition, and it stops just like you draw a line, and it turns into real gooey red stuff. Alright, this one here is just, it says YouTube, Megalithic Enigmas of Baalbek. You see on the end here? You see right there? That's vascular, that's blood supply. That can be checked very easy. You see this red stuff? That didn't just fall out of there for no reason. That is blood. This is a tendon emphasis point. And I'm going to show you another one that'll blow you. Alright, that's what it is. So somebody's got to look at this, but these are, hold on one second, I'll show you the stuff that I have in my own collection. Alright, I'm showing this is the tendon board after it sets up. And right there is what's called the abrupt transition. And this goes down to the bone and so forth to anchor. And then you come up to this abrupt transition. You see it right there? That's what it is. And they break just as straight across as can be. And there's anatomical. I have all the anatomical pictures of this and the microscope shots and the whole thing. Now, this is the vascularization. You see it? That the red one is the arterial parts, and the black one usually are the veins. Now, you go from this to the abrupt transition to the gooey stuff. Now we're going to go right into the muscular stuff. Now, the muscle fibers come out of this gooey stuff, and I think it's called leucine-rich proteins. You see some limestone still in here. The other ones down the other end are like literally made out of limestone. It's calcified limestone with mud fossil stuff invaded in it. Now, here's your fibers of the muscles, and these are the blood investments that feed the muscle tissues. And in the heart, you'll see they come not this way, they come towards us.